Hey guys, Joe Pye here. Welcome back to the shop. Next build is going to be the PM Research Mini Table Saw, and I'm looking forward to doing this. I've been wanting to do this one for a while. It's a little different. Taking a look at the print, and inside the box you can expect a bunch of castings. They're not bad shape. Wheels are nice and clean. And the bags of assorted accessories, smaller castings, the blade, the belts, the raw materials, the fence, and the table itself. This should be fun. In the interest of keeping everything in order here, I think I'm just going to start with item 1 and work my way all the way to the top based on the item number. Very possibly going to go by the material that's loaded in the machine. It would be nice if the material was listed on the side here, categorized based on what are you going to do with it. You're going to put it on the lathe, put it on the mill, it's going to be an 1/8 inch collet, 1/2 inch collet, whatever. But it would be nice if the material were called out that way. That is the way I try to do a print or a drawing when I make a drawing, instead of like this. Nothing wrong with that, but a little cleaner, a little streamlined if they are grouped up. So I'm going to start with the frame itself. Frame itself is this big guy in the center. Not a whole lot of detail on that. It's got to be sanded down, blended down, filed down, finessed, and cleaned up. A couple of holes drilled in it, a couple of slots. And on paper, that looks like this. This is not going to be as sophisticated as the mill or the shaper, but it's going to be another part of the little machine shop that I hope to make. So let's get to it. Take a look at the raw casting. It's not too bad. Flash lines are manageable. Everything seems to be aligned fairly well. A couple of gates on the bottom got to be sanded off. This has all got to go. All these lines got to go. Actually, when it's done, I want it to look like a seamless molded part with absolutely zero defects on it. And the only way to do that is to take your time, break out the files, turn on some music. All right, let's do it. When I start filing on my raw casting, the first thing I do is knock all the big ugly off and then blast it and evaluate it and come back and just keep on going until you're happy with it. Hey guys, after I would say a couple of hours of tedious filing time, I was able to remove a lot of the flash lines and give it a preliminary blast. Now, for those of you that are going to ask, I use a number 6 glass at about 60 psi. And it seems to work really well on this aluminum. Blasting it does accent some of the inclusions in the casting. And what you care to do at this point, that is entirely up to you. But this ugly right here, I got to make that go away. There's nothing on the print that would preclude me from knocking the center out of this, opening this up a little bit, going a little deeper here and filing some rounds on that to make that go away. I just might have to do that because that's going to bug me forever. And if you're not pleased with what you see, don't stop. Blast it, file it, blast it, file it, sand it, keep on going. Give you a look at some of the files that I use here. Quite a variety of files. Got some curved die files over here. Gift from a subscriber, thank you very much. Half a dozen round files in a variety of grades. Jeweler's files, these are the ones with the curved surfaces. I like to use the oval one. That works really well. And some heavy flat ones over here for doing large surfaces. So we're going to see if we can take a few more of these low spots out. I like the little shadow you can see right here in the center. And maybe this one in the front. This I got to take care of. That is just hideous. All right, give me a second, I'll be back. All right, guys, a little repeat tip here for those of you that have not followed all of these model builds. You can see one of the parting line features in this mold, or core insert, whatever this is. This is a step, and that is an unacceptable step. So I will do this repeatedly throughout the filing process to enhance the defect that I'm looking to erase. Okay. Right now that entire surface has got some red ink on it. The crack has got some red ink on it. I'm just going to pass a file over the outside of this and show you exactly how that just pops when you do it. Take a look. Watch this. Oh, see the crack? You know you just got to go deeper before that comes out. That really is a fantastic way if you're trying to work an inclusion out of a casting. That's a great way to do it. Now, unfortunately, this camera is right in my line of sight, and this is going to be extremely difficult to do on camera. So I can just make one section of it go away just to prove the point here. And if you're not sure of how you're holding your file, guess what? Ta-da! Pop the cap on the Sharpie and ink it up again. Let's do it. You can also change the direction of your file, which changes the reflection of the light that you're using. And that's also a good indicator of how you're holding your file. I don't know if you can see that happening or not, but it's plenty clear on my end. It goes from a really bright silver to a dull gray and back again. Okay. See that it's starting to go away in the center. Don't get carried away until you've cleaned up the whole surface. And then by all means take and round it off so it looks like the other side. After the blast, you'll never know it was there. It's a good tip right there. Little plug for American Rotary. Phase converters out there. Got this at Stan's Bar Z Bash. Thanks, guys. Well, the filing is done to my satisfaction, and I've got the part strapped to one of my little fixture plates. Let me talk about the logic behind this setup. This is very fragile, and I would imagine if you squeeze down on it with one of these Kurt vices, you could shatter this fairly quickly. So I've established the backside flat with a file. I wiped it down with a file, set it on a flat surface, and looked for it to stop rocking. When it did, I strapped it down to this fixture plate with clamps across the center window. You can see the engagement here. It is up on spacers. With it in this presentation, it gives me the opportunity to drill all the side holes. And I'm taking it out of that fixture setup. Let's open up this vise a little bit more. There's a perfect opportunity to mill the bottom, which is what I'm going to be doing first. By connecting it to that fixture plate, it has given me the ability to manipulate this irregular casting quite confidently on a hard parallel surface. All right, let's get a cutter in here, chop these flat. Now I have to admit that I used a probe on this, not a digital probe, but a hard dowel, and I just lined it up visually so that I believe everything is going to have sufficient material when I'm done milling this off. Okay, nice and solid. And while it's in this particular presentation, I may take a dust cut across the back of these two legs only, just so that I have a reference surface for rotation when I ultimately flip this over and do work on the top side of this part. And I know which side is which because we have the PM Research elevated logo and machine number on this side and not on this side. So that'll be my banking surface here and here. Let's do it. One aspect of this machining process right here that's not clearly obvious on the screen is I'm going to establish one leg clean and set my table height dial to 0. I am going to drop the table and come back to that Z0 for each one of these legs. So there is a table shift in between each cut here that may not be clearly obvious, but you can see it if you look for it. This is just a little safety margin in case there's a drastic difference in the height of one of these feet, it's not going to be a major impact when the cutter comes around. And I'll take the outside dust cut, the reference cut that allowed me to reproduce the position of this part at a later date. And yeah, I did all 4 legs. Okay, the bottom is nice and flat, and we have reference surfaces that are parallel front to rear. I'm going to rely, like I said, on the rear because it's, you know, the front. I'm choosing to do the back. In this presentation, I'm going to drill and tap the stud mounting holes that will mimic this thing being bolted to the floor at final assembly. So drill and tap 4 corner holes as you see fit. There's nothing on the print about this, but I normally use a 540. I believe a 540 flange nut will fit on the opposite side. So I'm going to visually line it up with a pin and a drill chuck, record the dimensions on the drawing so I can mate it to the floor that I mount it to, or the base that I mount it to at a later date. We'll go from there. Drill and tap the holes, be done. Guys, if you don't have a small tap handle like this in your arsenal of tools that you've made over the years, by all means, make one. I drive my smaller taps from the body of the tap and not the square end. If it's a tougher material, I'll drive from the square end. I may extend the square end by side grinding it on the pedestal grinder if I have to. But if you don't have one of these little guys, it really does increase your feel. This was a gift from a subscriber. Thank you very much, and I love it. I have several this size, but the brass just looks good, so let's keep going. Next feature in line is a 500 gap right between these 2 bosses here. Now I know I don't have any room back here for any type of measuring instrument, but I do know that it's a 185 shim and a 375 plate. So I'll measure the stack here. I will measure this, back this thickness off from the shim to the back, and adjust my y-axis 0 accordingly, so the 500 resulting slot is in the center of the casting. Do it. Next feature in line is a 256 tapped hole in this back lug at 5 degrees. Since the center of this casting was established cutting these slots right here, I'm going to use the same y-axis 0 for this. And the dimension is given from the upper edge of the casting out. So I used the pin and the drill chuck until it came in contact with the casting, made the appropriate offset, and we're going to drill and tap a hole right there. 5 degrees. The plate itself that the casting is mounted to is sitting on a 5-degree block, kicking it this way. Let's go. All right, with the part positioned at 90 degrees to the previous setup, I'm going to drill the 2 pivot holes, one for the drive pulley and blade, and I guess the other one is for the articulation of the table itself. Because of the distance between these 2 tabs right here and the unlikely possibility of the drill maintaining a straight trajectory, I've got a piece of slave material in here that's, we're going to center drill it, drill, 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 and then ream through. And this is just simply going to keep everything in line between here and there. That's the thought. Let's see what happens. That's a good trick. It works well. I've used it in the past. There's only one other hole to be done on the side here, and it's down here on the bottom. Kind of boring, just a simple 063 hole through. I will use the same technique. Well, you've seen it once, you've seen it forever, right? All right, let's pop this thing out, reorient it. The next setup in line is the preparation of these top surfaces here. These are the surfaces that will hold the receivers that hold the pulleys that drive this little machine. Now for this setup, I've got the fixture plate 1/8 of an inch below the hard jaws of the setup. That way I can use the finished edge of the part that I just cleaned up. You saw me do it. I'm going to pull it forward and rock it against this surface right here and use that as my alignment for the X and Y. I have a single clamp across the center back here, very gently tightened down. I don't want to distort the frame. And a clamp in the front with spacers underneath to keep any distortion out of there. This is a rather long drop right here and almost impossible to get completely to because of the ears on the top of the part. So I'm going to do this with a fly cutter, a rather large setting diameter on the fly cutter. And the fly cutter will run out and end back here somewhere. So let's cut it, see what it looks like. I think you can see the benefit of using a tool like this. You can get beyond the undercut and past this as well. So let's clean it up. Gently, gently. Small cuts on this one, guys. Small cuts. Nice clean surface front to rear. There is a reference thickness on those flanges, and I think I'm just about there. The other beauty of a setup like this, with the base being in line, I can tram in between the bosses up here for the center line and make sure that all the work that I do out here is symmetric about center. Okay guys, I think I'm going to call this one a day right here where it is. Got the main pivot holes reamed in, got the front plane down, everything is clean, filed. And for anyone that's going to leave a comment about, hey, a table saw is never up on the legs, there are not going to be legs. They're going to be fake studs that make it look like it's bolted to the floor. So save the comments on the leg detail. I'm well aware of that. Tapped holes in the front here go in at installation. Or excuse me, go in at assembly. So they got to be mated with something else. We're going to hold off on that. And there's a cross hole that goes in the side here that needs to be referenced from this surface here out. And that surface needs to be machined. So I'm going to have to hang this one upside down and machine that pocket out of there at another time. So there you go. Thank you very much for watching. I do appreciate it. Wherever you are in the world, I hope you're well, happy, and safe, all the above. Joe Pye at Advanced Innovations in Austin, Texas. I'm out.